Welcome,
My
everybody.
name is Matt Schrader. I'm the Director of Real-Time Data at Improving.
And I'm Andrew Kolb. I'm a Senior Architect at Thrivent Financial. And this is our presentation, Beyond Monoliths, Thrivent's Journey Toward a Modern Data Architecture. I'm going to lay some context out. So if you're here to try to find out what you can learn from our journey, I'm going to lay out what might or might not apply to your company and your data journey as well. We're going to go into the Thrivent integration platform, which is how we solved a lot of our data issues. Then Matt and I are going to break down 3 key engineering practices that we use to enable this data journey. It's not a complete list, but it's a good summation of things we did. Then we'll talk through successes, failures, and some final thoughts. So Thrivent, what even is that? Thrivent is a diversified financial services provider. We've got advice products, mutual funds, brokerage, trust, insurance products, annuities, all those things. We're over a 100-year-old company that's member-based. We've got 2 million members, and we're based in the Midwest.
Improving. Who are they and why am I up here with Andrew? Improving is a modern digital services consulting firm. We have expertise across the stack, but today we're going to highlight event-driven architecture and some of the ways that we assist clients in this journey.
So starting out, I want to lay out that context. What's unique about Thrivent? One thing is we have pretty long employee tenure. We're a company where I've been there 6 years, and I feel like the new guy on the block in a lot of departments. I don't know if you guys can relate to that, but it's pretty unusual, I feel. And that means we have a lot of varying skill sets. Many developers with mainframe backgrounds or other older skill sets as we're trying to do this data journey. Another thing is we're a merger company. So 2 companies came together to form Thrivent 15, 20 years ago. And we have a lot of systems of record as a result. Life insurance, health insurance, annuities, brokerage, mutual funds, trust have their own, and then every single one has multiples. So we have over 35, and that's what you get when you try to sync all that data together. It's a very complex problem. So what is the lava layer? Why do I have this up here? I'm talking about that picture of what our technology looks like it's lava flowing out of a volcano. So you have the things in the back that are dried, crusty, very hardened in. Think of like the mainframe back there. It's pretty much always been there, it's always going to be there, and you build these new things like the new lava rolling on top of it. So we've got, I'm doing this from a development perspective or a deployment perspective, we got WebSphere, we moved to Tomcat, and now we're moving things into OpenShift and Kubernetes-based deployments. I could do this same chart with a number of different solutions, not just deployments, but it gives you a feel for how a lot of those things are built on top of that old technology. How do we cut through that so that we're not just perpetuating the problems that we've seen today? Commonalities we have with industry, we have prevalent monolithic architectures. Anytime I say mainframe, everybody thinks monolith right away, which is correct. Because we have that, we have pretty low integration capabilities. I'm on the integration team, and as a result of that, we've got to find a way to, again, cut through that and find a way to deliver that data that right now is dark data and not available for people. The last commonality is one I've heard a lot since being at the conference. It's different consumers having the same needs. For us, integration kind of feeds most of the operational business units, but the data analytics team also needs that same data to drive things like real-time decision-making, AI going forward, et cetera. So what's our destination state? We want to go from that monolith to a fully integrated experience. How do we do that? We do it with something called this Thrivent integration platform, and this has been our strategy for the past few years. What is that Thrivent integration platform? My boss wants me to read this. A seamless, flexible integration experience that provides fast, consistent data across all channels using standardized, reusable products at enterprise scale. What that really means is we just want to simplify data access to cut through all of that. And what we're going to do is look at that blue layer today and show how we've managed to simplify data access using our technologies.
Yeah, let's talk about this blue layer in the middle here. So diving into that layer, what's actually happening under the covers is Kappa architecture, where we have ingestion. The first thing we need to do is get our data into Kafka. We do this via a variety of ways. We want to meet the data producers where they are and make their lives easier to get the data in for our needs. That may be CDC technologies. That may be file ingestion. Some teams may be able to produce to Kafka already, and that's fantastic. But ultimately, this data flows into Kafka so that we can get it into our speed layer where we actually work on it. This is where we do processing, aggregations, joins, transformations. We turn the data and what it needs to look like long term. We're combining systems from the slide earlier with all the databases, turning that into a better view for our consumers. This is the serving layer. We put the data into technologies that meet our consumers' needs. Quick access, NoSQL. Full text search, put it in a search database. We build APIs on top of this, and one unique thing that we're doing at Thrivent, oops, oh, that's just showing up there. One unique thing that we're doing is we're aligning our APIs and events together via common schemas. If you come to our APIs and you're expecting the data to look a certain way, you can trust that our events mirror that, meaning you can move to an event-driven model as your team is ready for that rather than being forced on that journey. So today we're going to talk about three of many things that we focus on, three engineering practices that are critical in this journey.
So I'm going to take the first one, and it's using schemas. I've been to like 4 different talks already that have talked about the importance of schema usage, so it felt validating to be able to have that come through in my talk today. We actually are using JSON Schema for ours, which I'll talk about why in a little bit. But let's first talk about why we're using schemas in case you're not already convinced. First, they shorten the design feedback cycle. We build our schemas, we build API specifications, we build event specifications, and we get the ability to get feedback from consumers on what the data contract is that they're going to receive immediately. We don't have to build anything to get that feedback. The design cycle is shortened. That speeds up our integration build, which allows us to build at the same time as consumers are developing against that same data contract. So we're doing parallel development. Again, we can do parallel development with our QA team. We now enable test-driven development because we have a data contract in place that the consumers, the producer, and the QA team are all building against, all without writing a single line of code. The other thing that you get with your schema is that you get documentation up front. I think this is underrated. A lot of times when people build out projects, the documentation is sort of the last thing, it's an afterthought. But when you force a schema to happen first, you force that documentation, the most important piece of documentation to be created at the outset of the project. Ultimately, what does this all add up to? It builds trust. You're gonna hear us talk about building trust a lot during this. So once we decided to use schemas, kind of a no-brainer, what were our goals? One, we wanted to have a unified data definition for API and event consumption. So not just API consumers use one schema, events consumers use another one. How can we unify these two things so that everybody's using the same schema regardless of their consumption mechanism, and they could switch theoretically at any time between the two of them? Secondly, how can we reduce the effort required to create these things? How can we make it so that our API schema and our event schema rely on the same underlying background so that we don't have to create duplicates and potentially introduce problems? And lastly, how can we use our tooling to automate everything? The development teams want the right path and the easy path to be the same, and we'll show how we do that in just a second here. So you'll see on the left side there, just an example of a JSON schema we have. You probably can't read it very well, but it's just some contract data. We have a contract number, we have their product type, and then we have some references to relations of people that own the contract or are maybe a beneficiary on it. And what you can do then is take those JSON schemas and refer to them in other documents. So starting with the JSON schema, we can then refer to those in the API spec. Obviously, you have to put in the methods you're going to use for HTTP and the types of responses you're going to get, but the underlying domain objects are the same for the JSON schema, which we then use to populate our event schema. Because we're using JSON schema, it's acceptable to Kafka, it's acceptable to the OpenAPI spec or OpenAPI 3 specification that we're using, and we now have that underlying layer that's the same. But we get other things too. We can generate a domain jar that's shareable to all the development teams as they want to consume this data. And finally, we can use that API specification to go even further and generate JavaScript clients and API clients for our Java consumers as well. How can we do this in a way that's easy? We can use our CI/CD pipeline. So you can see, as I've illustrated here, we've got first the JSON schema generating that domain jar, and then finally we have the artifact repository getting both the JavaScript client and that Java-based client. We can upload our API spec to the developer portal so that whatever is in the environment is guaranteed to match with what consumers are seeing in the portal. There's no manual pushing of anything. And we can do the same thing to upload to the Confluent schema registry. So you've now made sure that your data contract is the same and available in all the different mechanisms that consumers will be looking to try to find your data, and it's discoverable, it's clear up front what they're getting. I made that sound really awesome, at least I hope I did. But the pain points are real with this. It's not as easy as I've made it out to be. One, this requires code gen tooling, which if you've used code gen tooling, you feel my pain a little bit. We've had a good time generating some things, and we've had a hard time with other things. But it's a great place we think open source could help, and where maybe our company could even contribute back to open source. Another one was the API spec linting, not quite as friendly with JSON schema as it is with other types of formats. So we had to give up a little bit of security in order to get that united data contract in place. Trade-off. Lastly, and this goes for any time you start using reusability, you can have gigantic dependency chains of these schemas relying on each other, which can become super unintelligible and make your build pipeline a clouded mess. So sometimes abstraction is beautiful. Sometimes it might be better to violate dry just a little bit. So that's use schemas.
Yeah, so we leverage schemas. Schemas build trust in our data. Trust leads to adoption. I'm going to pivot a little bit from the consumer point of view to the developer point of view, because the data is not in that serving layer by default. Development has to happen to get it there. So I'm going to talk about governance now and how we enable developers to do their job more effectively. We've all introduced Kafka into our companies, and this is often what happens. Put it out there and hope for the best, but we could do better than that. We can empower our engineers to safely build, and the key word here is safely. So the goals that we have here around infrastructure are to be able to declaratively provision it, provide reuse via modules, collaborate on it just like any other form of development, and along the way build in security, compliance, and cost management features, and automate, another theme of this talk. You maybe predicted this already from those last bullets, but our toolkit leverages Terraform, Sentinel, and CI/CD to automate it. So I'm gonna dive into each of these and show how they work in our flow. First with Terraform, which if you're not familiar, it codifies your cloud APIs, meaning if you need to provision AWS, Confluent Cloud, Azure, across all different clouds and various providers, Terraform can bridge that gap for you. These bullets kind of reiterate our goals, but it allows us to create that reproducible infrastructure, collaborate, and ultimately avoid click button infrastructure. And what I mean by that is, I'm sure all of you have gone out to the AWS console for a demo, created some stuff via the UI, and never created it the same again. It's impossible, I think. So this avoids that. And once again, if humans are involved in this, we're trying to automate it to make our lives easier here. So let's walk through the flow. We have an engineer one. Let's say that this is me. I need to provision some Kafka topics in Confluent Cloud. I would write that code, check it into our repository, and Terraform is watching that. When Terraform sees the changes hit the repository, it's going to write a plan and tell me exactly what it proposes it's going to do in our environment. It looks at what's out there, looks at what I'm about to do, and it gives me a diff. It basically says, I see you want to create these two things and destroy one topic, and now I have a chance to say, yep, that's what I wanted to do. We now move into our typical development flow with the ability to review that infrastructure. So Andrew may be on the other side looking at this plan. He's probably complimenting it because he's a kind guy. And then he'll hopefully approve it so that we can get it into our environment, which is where Terraform then does an application. It takes that plan and it actually applies it to the environment. So now the topics are out there. I didn't click any buttons. I wrote some code that's tracked in Git. We have a full history of it. It was peer reviewed. This is a safe way to get your infrastructure out there. Engineers are now empowered to provision any infrastructure they need. But engineers are now empowered to provision any infrastructure they need. That's not always a good thing. So we need to automate and put guardrails around our teams so that they can do this safely. Sentinel is how we're doing that, which is policy as code. Very similar to Terraform, except for it adds the policy to it. This allows us to enforce compliance, governance, cost reduction, all in one spot, and it fits right into that flow that I just showed. The Terraform plan comes out saying, Matt wants to create 2 topics and delete a topic. Sentinel would evaluate that and see if I'm allowed to do that. There's different policy types that you can apply here, depending on the seriousness of your policies. So advisory, this may be you just letting the consumer know that they probably shouldn't do that, but you're not going to stop them. Soft mandatory is similar. It's going to fail the build, but it can be overridden. And hard mandatory, these are the rules that you simply can't pass. So let's add this to our picture. We have our plan. I'm going to create 2 topics and delete a topic. There's now another engineer in the mix, likely, who's writing the policies that apply to our teams. This engineer is putting these policies in code. They're version controlled. And so next up, Sentinel is going to take that plan and apply rules. This could be topic naming conventions, topic sizing limits, topic retention limits. All sorts of things can be applied via Sentinel. And once the application of that is done, we now move into our peer review step where Andrew would hopefully approve and apply the topics. So now engineers are empowered to provision the infrastructure they need, and best practices are built right into it. Lastly, we wrap it all up and automate it via GitHub Actions in this case. So this is a simple flow illustrating our governance process to give engineers the power to build and do it safely. Schemas are leveraged. We govern who can do what and how they can do it, while at the same time allowing them to build. Lastly, I'm going to talk about observability. If you were at my lightning talk yesterday, some of this will feel familiar, but I like this quote. A system is observable if and only if you can determine the behavior of it based on its outputs, and I'll show you what I mean, but the goal that we have here is to collect and observe everything by default because this is very valuable data in distributed systems. So here's that same picture, and imagine as an engineer that it actually looked like this to you. Right now, the outputs that we have are whether or not data comes out the other side. So events are flowing through this box, and I can see that it's going well because they show up on the other side until they don't. And then you're left with this exercise of, where did the data go? And I point at Andrew. We can do better than that. We can start to collect information to drive our decisions and understand what we're building better. You already know this, but logs, metrics, traces, these are the 3 big buckets in observability. And I'm going to talk a little bit about traces here and what we're doing. So this is a generic service graph showing data flowing through. Service C is a HTTP service, and ultimately what we want is to build a picture like this, where I can see lineage, bottlenecks, flow of data. And so we need observability to do that, and it's not just magic. There's something that has to happen here to build that picture. We're leveraging OpenTelemetry in this case, and there's 2 main reasons that I think OpenTelemetry is very appealing. First, it's vendor agnostic. It was born out of the need for a protocol and a set of libraries that aren't strictly tied to the vendors in this space, and I think that's important to avoid lock-in while still getting the features that they promise. It does have instrumentation in 9 different languages. So whether you're a Java shop or something else, these apps can all play and talk together. It comes with a collector, which I'll show in a minute, and it supports multiple context propagation formats. What this means is that if you're already partway on your observability journey and you're using a certain set of tools, OpenTelemetry can likely speak that language while you try to bridge the gap and get into newer technologies. So it can help you migrate into modern observability frameworks. Second, auto instrumentation. No code changes required, no dependencies required. You can attach this to your apps as is, and it can start to communicate and instrument your apps and give you observability from a tracing perspective. It has low impact on performance, and it's configured via environment variables typically. So now what this picture actually looks like, each of these services have something attached to them. The OpenTelemetry agent and they're all speaking the same language, sending that data to a backend such as Elastic APM. This is great, but we can do better. We can introduce a layer in here to protect ourselves from a single vendor being our only option, which could be painful in the future if we switch vendors. So the OpenTelemetry collector is a best practice in this space to get deployed to insulate your apps from your observability backends, and it also provides capabilities like tail-based sampling. It centralizes secrets. There's a lot of benefits to this, but I think one of the most unique benefits or best benefits is around the ability to export to multiple places. So we can send our data to Elastic, Datadog, back to Kafka. We can start to send it where it needs to go based on the use case because we're collecting a lot of valuable data here. We should be able to use it how we need to use it. A few challenges that I think are notable: mixing and matching tools and agents. So if you have teams, let's use Datadog as an example. If you have teams that are using the native Datadog agents and teams using OpenTelemetry, by default, they don't speak the same language. They propagate the data differently. Datadog sets a certain set of headers. OpenTelemetry expects a trace parent header in this case. They're not talking to each other, but there are ways to line them up and make them speak the same language. App-level instrumentation. So to get this up and running, typically you could attach it to each app, but any change required is a change for each app's config, which can be painful as this scales. There are better ways to instrument your apps. There are operators in more declarative ways. So you could deploy your app annotated with a certain Kubernetes annotation, and the operator automatically instruments it. That's an ideal state. Lastly, finding the value. An immense amount of data is going to be pushed out of your systems as soon as you flip the switch on this, and it can be overwhelming to find the value in that and figure out how to make sense of it. You need to take time to understand what you have, what your goals are, and how you want to extract the value from this very large but valuable data set. So we've talked about schema usage, governance, and observability. Now Andrew's going to talk about a success story.
So I want this to be pretty synthetic at the end, kind of tying this all together. How did this actually look with a particular solution that worked? So one example we have is with a document generation team. We had a product mailings team, and what they need is to create mailings on a customer basis, client basis, and for each variable product that a client holds within their particular insurance product, they get a mailing that's for security law mailings. What we saw originally was this, and it's a point-to-point solution, not very reusable. All the data is in kind of the document generation domain, and they modernized a little bit once we had RabbitMQ in place to send the data via something other than a file, but ultimately it wasn't a super scalable solution with a ton of visibility. There were times when they would run this and something would go wrong. You have to start from the beginning, feed the files back in, run the whole thing again. So a very difficult process for them. What we did in our case is revamp the solution end to end to make it more beneficial for the enterprise and for this team in particular. So first, you see all of our data sources on the one side. We enabled CDC, and that was big for just kind of cutting through all the existing processes of having to use a file-based system from the mainframe or some other mechanism to getting the data out, IBM MQ maybe. CDC is clean, gets it into Kafka right away, and allows us to bring it in to do stream processing. Once it gets into that enterprise services domain, we use the things that we just talked about today to define the data model. We've got a JSON schema. We expose the data via both a Kafka enterprise topic, which they consume, and an API, which they didn't use for this particular use case, but it's available for others in the future. As we iterated through this, all the benefits of version control and versioning of your code are available to you because you declare your data contract at the code level. The next thing, once it was all implemented, or as it's being implemented, we had observability on all of the things within our domain. So you heard Matt talk about how it came without any code changes, any dependency adds. We just changed the base image we use to deploy to include the OpenTelemetry agent, and boom, we can see exactly what's flowing through, how fast it's going through Kafka, where the bottlenecks are, is it struggling going into the database, something else. It allowed us to tune the solution without having to rely on our consumers to tell us things are going too slow or too quickly. It's also worth noting that that entire purple box around Kafka topics and stream processors was done using the self-service infrastructure, so provisioning via Terraform, using the Sentinel policies, and it allowed the teams to own it themselves versus needing to rely on a platform team to configure it for them, putting in tickets, and only in cases where there were things that were sort of like questionable or like needed special cases did they have to get anybody else involved outside of their team. It's owned by them. The last thing I want to underscore is just on its face, this architecture is better than the previous one, everybody can see that. But it's not just about what was built, it was about how it was built too. The what is using good enterprise principles to design your solution and not have point-to-point integrations. The how was we now have observability, we have governance, we have automated provisioning and self-service, and we use schema, contract-driven development. All those hows scale into the next type of solution for a different domain if you need other types of data. The what scales across the number of consumers that you can have beyond just a document generation team that might need this particular data set. In this case, we saved 250 hours just in build work when they needed data from a different system. So they could have either updated their old system to just include a new file feed or a new queue feed of data. And that doesn't seem like a lot on its face, maybe for just build work, but now it scales out to the rest of the enterprise and allows them to not have to worry about it going forward. They just consume from our topic and they're able to benefit every single quarter. As there are issues, we can show the observability and let them spend less time working on this overall. So that's sort of it's a decent number starting out, but it's going to scale really quickly as we get further and further into the future. Again, this wasn't perfect, so there were failures, or as my boss likes to call them, opportunities. My friend Jason Mendoza likes to call them pre-successes. Not failure, you're pre-successful. So where were we not successful quite yet? One is we tried to do this for a lot of different domains. I showed one particular one. We didn't finish one exact one and do the whole thing as a complete product. We were kind of parallel building a couple of these, which meant that there were certain features that we didn't get to implement all the way end to end. One example, and if you've dealt with this, I'd love to hear from you, is data reconciliation. We've kicked it around a lot, trying to figure out how we can assure people on the consuming Kafka side that everything that was in the systems of record made it out into Kafka. What can we do to detect that there was a problem? What can we do to compensate or remedy the problem in an potentially automated fashion? Even a manual fashion would be highly valuable. The next thing is when you do something like this, you need to really focus on relationship building with both your consumers and your system of record teams. So you can't move too quickly, and you have to make sure that you bring them along for the ride with everything. You end up introducing yourself and you're part of the organization and what you do over and over again, and you can't have a bad attitude about it. You've got to be, give them some grace, be trust-filled, and make your way around the organization, making sure that you develop all those relationships to get the best delivery possible. And once you do one, that scales out to the rest of the organization because hopefully your consumers become your own advocates. Just a key thing that I want to underline, building trust takes that time. Losing trust can happen really quickly. As soon as we have a big production issue and they say, well, my old system was better, now we're in really big trouble. We've talked a lot about technical things today, and these would be great to implement. I would recommend, the things that we did, other people do. But I also want to highlight some non-technical, maybe organizational types of things that maybe don't get enough press from an engineering perspective. So I'm going to give everybody like 10 seconds to read this, and then we'll talk through why this is relevant. I really like this scene because at work I see a lot where people build this awesome solution and they think everybody should just kind of come and find it and use it. It's like, well, my solution is self-evidently great. Why isn't everybody just beating down the door to use this thing? That's not the way that life works. If you don't go out and market it, if you don't go out and show people the value and show people how to use it, it's like it's at the bottom of a locked cabinet, in a bathroom somewhere, with "Beware of the leopard" on it. So that can be your phrase, "Beware of the leopard." The last thing is just some organizational challenges. One, and I said this before, it's a unique journey for everybody. Thrivent's journey is going to be different than any other company's because we are a unique company. And the only thing I can guarantee you is that it will be very difficult. There's really no other guarantees. The next thing is, while we focus a lot on technical things, all of these flow out of culture. I read somewhere recently that if you rebuild a software system without a bad software system, without focusing on the culture that created it, you will rebuild a bad software system. It's really about focusing on engineering culture, blameless culture, ability to take risks, to learn, to grow, and fostering that throughout the organization. And then the last thing is making sure that you shorten the feedback loops. One thing that I really like about the way we've structured our organization is I'm on the integration team. We deliver integration products, but we also sit right next to the platform team. I report to the same manager as our platform team does, and they're able to get feedback from me on how to use things or give me feedback on how I might have done something better or different. So shortening those feedback loops throughout the org really gives you the opportunity to drive outcomes and improvements faster. That's it. Thanks for attending. Like and subscribe and upvoting.
Yeah, thank you.